Welcome, everybody. So, as I said, I'm Jeff Otterstetter from PPI. I've got Brian Riffle, our engineering leader, with us. So we're going to talk a little bit about who we are, our background, some of the applications that we have developed, and kind of where our future research focus is going to be. So we're a privately owned company founded in the 1950s with over 65 years of experience in aerospace maintenance, repair, overhaul, manufacturing. So our group currently supports more than 25 different platforms. So this includes things like the C-130, P-3, C-27, ATR aircraft, COS aircraft, Dash 8, Embraer, variety of aircraft running PT-6, LT-101, Rolls-Royce 250 engines. So we support civil and militaries in the U.S. as well as around the world. We're recognized as an industry leader in the industry that we support. We're a Part 145 authorized repair station, the EASA approved repair station. We have full machine shop capabilities, so CNC lathes and mills, manual lathes and mills, grinding equipment, etc. We also have on-site plating department, so this does include hard chrome, which cold spray is a very attractive replacement for on a variety of applications, and one of the things we're very excited to research and work further with. We have very strong experience here, so engineering team that supports production as well as R&D activities that we continue to expand. Our management team has experience with companies, working for companies like GE, Boeing, Smith, Moog. We've also hired some experts in the cold spray industry to help support this capability here. Quality is a big part of everything we do here because of the criticality of the parts that we work on. So we're AS9100, ISO, and a NADCAP accredited facility. Talk a little bit more about our aerospace group. So PPI, we're located here in Kent, Washington. So we focus mostly on hydraulic component and metal blade, MRO, as well as parts manufacturing. So our tech services division is responsible for setting up maintenance, repair, and overhaul capability in back shops around the world, covering everything from engines to propellers to hydraulic components. They also support our customers in the field for things like AOG situations and training. So CNS down in Fort Worth, Texas has become our Composite Propeller Center of Excellence and our clean facility supporting a variety of fixed wing and rotorcraft platforms. Precision Fuel Components, located here in Everett, Washington, close to the Boeing facility, is our division supporting fuel systems, MRO, and parts manufacturing on a variety of platforms as well. So Brian, our engineering lead, is going to talk a little bit more about some of the applications we have developed.
Hey everyone, my name is Brian. I'm the lead engineer at PPI. So today I just want to talk about a couple of repairs that we've been working on and developing that are applicable to the Hamilton Sunstrand, the 54860 propeller system, which is used on the C-130 and P-3 aircraft. So the first repair we'll just talk about is the sleeve set, which, as you can see the picture up here, is basically on the picture on the left side kind of shows a cartoon, which basically is composed of the sleeve set is basically composed of a rotating and stationary sleeve. There's two parts. The sleeve set mounts into a pump housing, which basically contains all the hydraulic fluid and the pumps that support and operate the propeller. And then the pump housing, once all that's assembled, the pump housing slides on to the tail shaft of that propeller hub assembly. The sleeve set basically provides really two functions for the prop system. One's being able to port the hydraulic fluid from the pump housing to the propeller to be able to do any pitch change for the propeller blades. And the second function is it's acting as a bearing, basically a plain bearing interface between the stationary pump housing and the rotating propeller. So basically over time, as that sleeve set wears out, and we usually have to scrap the part, or we do have a current process to reestablish that babbing surface. That current method is basically done by a spin cast melted babbitt process, basically where you take the sleeve set, you spin it up, and you pour melted babbitt inside the sleeve to build up that ID dimension, and then you finish machining it back into tolerances. But this process really is a very messy process. It has a lot of masking issues, controlling where that molten babbitt material flows during the rebabbiting process. So it's not a very I guess, a fun or a successful process, has a lower rate of success for us. And so we're definitely looking at the opportunity to really find a new process to apply and restore these, restore the babbitt surface in these sleeve sets. So basically what we did is we teamed up with Moog on, they helped us do some material development and spray development on the sleeve. And PPI, we basically from there went and did all the finished dimensioning work, or excuse me, the finished machining, and also we were doing all the final rig testing and qualification for the sleeve set. As of now, this project is currently in its final testing phase. We're basically have a functioning sleeve set that's been cold sprayed. It's on a working pump housing, and we basically put it on our test rig stand, and we do that we normally use for overhaul blade or overhaul pump housings to test and qualify those. So we basically have a functioning sleeve set and a pump housing that we're just running and putting hours on just to check and verify that that bearing surface is working properly. We currently have about 65 plus hours on a sleeve set right now, and you know, it's been holding. You know, when we take it apart and do an inspection, we do both a dimensional and also visual inspection. You know, they've been holding tolerances, and we haven't really seen any abnormal wear in the sleeve set so far. So that's our first main project we're working on. The second project we've been working on is and actually this one's completed, is a valve housing cover repair. It's I'd say it's very similar like a valve housing cover in your car that goes over the valve housing. It just seals the valve housing of the control. In this case, for the propeller, you have the pump housing, you have the valve housing, and then you have a cover that goes over the top of it. Usually what happens is that valve housing cover usually been in operation for a very long time and being removed in the field and put back on, that there's a sealing surface on the bottom that basically it wears out and it loses its flatness. Once that flatness is gone, it can no longer compress the seals appropriately, and therefore you get a lot of leaking you know, inside the engine nacelle. So really help mitigate this and control that, what we decided to do is develop a cold spray repair for that valve housing sealing surface, which you can see in the right-hand picture. The bottom right is basically the finish, and the top left picture is as sprayed. So basically, this sleeve just mounts, or this cover mounts over the valve housing. And some of the issues that we experienced from that was just like I was saying, out of flatness, and basically we weren't able to correctly make a seal. So from this, basically this is operational currently. The repair is basically an aluminum on a magnesium repair sprayed. This sprayer is currently DER approved, and we're currently using it now. It's in service, so it's a good repair.
Okay, we'll talk a little bit about the areas where our future research is focused. So with the success of the sleeve babbitt repair, this is an area that we're going to continue to further research because of its application in a wide variety of industries. So the pump housing that you saw before, we're actually going to be looking at repairs in the actual pump housing. So this is going to include the sealing surface as well as some of the internal pump bores, which will be a little bit more of a structural type repair. But these are parts that are another magnesium housing, very expensive, hard to find, so significant opportunity to reduce maintenance costs. Wear coatings are another place we're looking at. So I mean, the advances in this technology are very exciting. We heard about some of it earlier today. So our focus is mostly on applying protective wear coatings to things like actuator cylinders to extend the maintenance intervals and reduce maintenance costs. Aluminum structural repair is going to be another focus area. So we've seen some very exciting work done in this. So we're going to be researching some of those applications as well, largely around the dimensional buildup of wear parts and things like propellers. Composite propeller sheath. So many platforms are transitioning to composite propeller blades, both for maintenance and performance costs. So one of the opportunities we think there is to use cold spray to actually repair these nickel sheaths, ideally on the blade without having to remove it, because you frequently destroy it as part of that repair process. So one of the other things we're looking at is the gearbox housing on the T56 engine. I think there's about 18,000 of these engines that were built. They end up on a variety of different platforms. The gearbox housing does see a lot of wear, and it's another really expensive, hard to find part, so another opportunity for some pretty significant maintenance cost reductions. So, in closing, we're very excited about this technology, its possibilities, and continuing to participate in the R&D programs with all the other research partners and OEMs. We're building out our cold spray capability and team to become one of the industry partners that can help take this technology and implement it to reduce military and civilian maintenance and production costs in a reliable and repeatable way. So thank you for your time today, and we'll see if you have any questions.
All right, that's great. Thank you. So I got one question came in. This is about the Babbitt application. So, and I think you partially answered this, but is there any difference between the Babbitt that's cold sprayed versus the Babbitt that you normally put on with wear? And I guess on either side of the interface, so on the whatever the mating surface is, and then also was there any coupon level testing or anything of that sort that was required?
Yeah, so there's quite a few questions there. I hope I can answer them all. There was definitely coupon testing. Did coupon testing for the Babbitt material, for adhesion. We compared that with the original cast Babbitt to get a good comparison. At least try to be as equivalent as we could. At least to get a baseline of what the adhesion properties were of the cast material. What were the other questions? Can you repeat
how close the material was to the original Babbitt material? I think they're very similar, not exact.
Yeah, they're very similar,
very similar
in properties between the two.
Okay. So another question came in. How about certified repairs for aircraft MRO business?
Yeah, I mean, currently we're in the process of, you talking in general for one of these sleeve set, or is that?
Yeah, so that's part of, or maybe an overall process. So the big part of it, right, is validating the repair internally, getting through all of our quality control and all our requirements. Then depending on where it is, either working through a DER or the OEM or both to certify that repair and then implement it to the market.
All right. Another one is, what is the thickness of the Babbitt being sprayed?
That's proprietary. I think we can't specifically answer that one. Unfortunately, this one was a proprietary repair. So.
Okay. All right. No problem.
Thick enough to reestablish the what we need.
Yeah. Let's put it that way. Got it. And then there was another question that came in earlier that was, what cold spray equipment are you using?
Fair. We can't address those repairs specifically, but we do with our industry partners. So we have access to like the CGT, Centerline, Plasma Guidecom systems, as well as VRC. By the end of the year at our facility here in Kent, we'll also have a VRC system online and expanding from there as well. But it is a high pressure application.
All right, fair enough. Then I think that is it. Thank you very much, guys.